In this video series, we're going to take a look at the various steps involved to build this deck. From the very beginning, dealing with this old decrepit structure, all the way to the installation of the cable railing system. So stick around. My starting point with this project was this old deteriorating deck. It is a floating deck supported by cantilevered stringer boards. The deck doesn't look great, but to my surprise, these foundation boards look pretty good overall. They're straight, they're not sagging, and look solid near the house, the critical load fulcrum point. However, there is some definite rot near the ends of some of these beams. If not too bad, I might be able to cut the ends and reuse these stringers. Now, to take a closer look at the ends of the stringers, I started to remove a few of the old deck boards. These boards came up easily with a little persuasion from a crowbar. Most of the screws had rusted away, so there was not much holding them down. I was already getting a better look at the stringer ends damage, but I decided to pull a few more rows to be able to see how far back the stringer damage went. It turned out only a few of the boards had rot more than a couple inches back from the edge, so I decided I could cut off the bad ends to expose solid wood. It looked like if I cut 6 to 8 inches off, that should do the trick. I used a circular saw to carefully make the cut. Sure enough, the wood was in solid shape at this point. Next, I had to cut the same amount off each stringer. Now, the result with this move meant I could likely reuse the original deck stringers. However, I would have to sacrifice a bit of the finished deck surface. And since I had some paint around, I sealed the cut ends for an extra bit of protection. Next, I cleaned some salvage pieces of 2x10s to create a new stringer cap. Using an angle grinder, I cut off any exposed screws. Then I used a speed square to guide a circular saw to create square end cuts on the boards. I attached these sections as a stringer cap by using screws to attach them to the clean edge of the fresh cut stringer boards. I had some seams that didn't line up with stringer board mounting edges. I cut blocks out of the remaining scrap and placed those between stringers where a cap seam was present. I used screws to secure these blocks and now had a fresh new edge for the perimeter of the new deck. Now, for the few surface rot spots in the remaining old stringers, I cleaned out the holes and filled them with a Bondo type wood filler. This was primarily an effort to keep water from pooling in any low spots. Now I wanted to take a closer look at the stringer boards near the house side of the wall and needed to remove more deck boards to do so. I tried to remove screws, but many were corroded so bad there was nothing to bite with the drill head. A pry bar helped again to remove the deck boards. Since these stringers were holding up the deck, I wanted to make sure they were in good shape underneath the house floor. To do so, I popped off a cap board to examine a few stringers under the house. Thankfully, they looked good and made me feel better about the integrity of these stringers. And now at this point, I decided I would be comfortable building the new deck on top of these old stringers. But before I went any further, I wanted to go ahead and design and thoroughly plan the actual deck I wanted to build. I went ahead and I modeled using a 3D modeling software. This really helped with project conceptualization as well as making accurate material estimations. I highly recommend doing some sort of 3D model when you're doing an elaborate DIY project. It's so helpful on so many levels. To minimize water intrusion, I used a window flashing tape over the stringer and cap boards. I used small 2-piece sections of tape, making sure the upper tape overlapped the bottom, and I did this the entire length of the deck. I had to install structural railing posts less than 4 feet apart the length of the deck. The first post was to be attached to the brick wall using masonry anchor hardware. These bolts had to be in a precise location not to interfere with the cable railing hardware, so I started by making a template with a scrap 2x4. Holes were pre-drilled in the accurate locations, and then I placed the template in position on the wall. I drilled a bit to make a mark for the first hole, and then, using a hammer drill with a masonry bit, drilled the depth of the first hole deep enough for the anchor wedge bolt to be installed. Then I temporarily placed the bolt backwards through the top hole of the template to hold the template to the wall. This allowed me to position the template in a proper plumb position before drilling the hole for the second anchor bolt. Next, I partially set the anchors by tapping them into the holes using a hammer with nuts on the starting threads to help minimize any possible thread damage from the tapping. At this point, the anchors already felt solid. Then I placed a pre-drilled 4x4 made using the same template over the bolts and persuaded the post into position using the hammer. I added a washer and nut to each bolt and then tapped them even deeper into the wall to maximize the anchoring strength. Then I used a socket wrench to seat the wedge anchors and firmly secure the post into position. Next, I attached mason string to the top outside edge of the post and ran it to the end post on the other side of the deck. Then I ran the line from the top of the corner post back to the top of the first post. These two strings would enable me to set the proper height and alignment for the remaining railing post. For this project, I used 4x4 pressure treated post. After marking for length, I used a speed square to mark a cut line on one side of the post. Then I transferred that line to 3 more sides of the post. I then set my saw blade to the max cutting depth, which is not enough to cut through the post in one cut. After the first cut, I turned the post over and made another cut on my other traced line. By cutting 8-foot posts in half, I ended up with 2 posts per cut. Before attaching the posts to the deck framing, I decided to beef up the framing where the posts were to be attached. I simply scabbed on another 2x10 to do this. Notice this little triangle scrap board. I have it temporarily attached to help hold this board in place, as well as a place to set the post on when I go to attach it. Now I could set my post on a temporary ledge and set it in proper position. The goal was to line it up with both string lines and then make minor adjustments to keep the post plumb. In some cases, I needed to use shims. Then I tacked the post in the proper position using a couple of deck screws. To make the connection to the deck framing solid, I used 1/2-inch galvanized carriage bolts and needed to drill holes through the framing and the post to install the hardware. Then I was able to tap the bolts into place and add washers and nuts before tightening. I set each post in this fashion, and thanks to the guidelines, I ended up with a perfectly oriented rail post. Next, I was to install the top railing boards in between the post. To do this, I placed dry 2x6 pressure treated boards on top of the post and traced cut lines using the post tops as a scribe. To accommodate for any irregularities in the post, I had to adjust the angle of the saw accordingly to cut along the scribed lines. These boards would be attached by toe-nailing screws into the boards and post. I pre-drilled for the holes and then marked the center location on top of the railing board. I also marked for center of the rail post and then loosely set my screws to ease the one-man installation. Before inserting the rail, I added a temporary holding screw to hold one side of the rail board up, kind of serving like an extra set of hands. I set the board into position, lining up my center lines, and then carefully screwed the board in position. I repeated this process for each of the railing boards. Now, worth mentioning is installing the boards in between the posts like this will help offset compressive forces from the cable railing system. Basically, this will help keep the corner post from bending over because the rails will transfer the load all the way over to the opposing wall. I ordered pressure-treated lumber for the decking. It'll work well for this project, but since it is wet from treatment, it will shrink and leave some gaps as it dries. Now, I left some of the old decking in place to be able to work off while adding the new. I lay the first board tight to the patio edge. I'm using 3-inch stainless steel deck screws, 2 per joist. I start at one end of the board and then go to the other end to bend the board in position before securing it with the screws. Then I could install screws over the rest of the joist locations. This deck is long enough it needed 2 2x6 decking boards to cover the span. I planned on a staggered seam and added 2x boards to the stringers where the deck boards would meet. This would allow for better deck board support, as the end of each deck board would be secured to independent boards. I like to install this type of lumber with the end grain in an upright rainbow position when possible. Now, some people say to do this the opposite way. Please let me know in the comments below which you think is the best way. I continue to lay and fasten deck boards from this point, making sure to keep the boards tight to each other and using 2 screws per joist. I demo the old deck boards as needed and remove any old fasteners in the stringers before adding the new deck boards using an angle grinder. To create the staggered seam, I had to cut some deck boards to length. I used a speed square as a guide for my circular saw to make the cuts. At the deck board seams, I would often set the screws here first, then secure the other end of the deck board, and then screw off the rest of the board at the stringers. At times, I would still end up with a gap between the boards due to the nature of real wood lumber and its imperfections. To reduce the gap space, I temporarily screwed a scrap board to a stringer to use as a pry point. I took another longer scrap deck board as a pry bar and forced the board into a tighter position, secured in place with deck screws before removing the pry board. Thankfully, the deck boards are fairly springy if you have a good way to apply a pry force. Now, before finishing the decking, I painted the rail posts and top railing, thinking it would just be easier to do at this point. The last two deck boards needed to be smaller in width for a proper fit, so I ripped them down the size using a straight board as a saw guide. I also needed to compensate for the rail post. To do this, I set the deck board on the edge of the last deck board. Using a square lined up with a post edge, I measured the space between the deck board and post edge. I transferred the measurement onto the deck board and then drew a line to mark for the cut. I repeated this process for the other side of the post, measured and marked a line, and then using a straight edge, connected these two lines. Now I had the area to cut out so the board could fit nicely around the post. I repeated this process for each post. Now to cut out the space, I started with a circular saw to make some starter cuts, and then I transitioned to a jigsaw, orienting the blade slightly at an outward angle. I did this because with this saw, the saw blade sometimes bends inward, and it is helpful to have more room at the bottom of the deck board cut for installing the deck board. In hindsight, it probably would have been easiest just to complete the entire cut with the jigsaw. I decided to pre-drill the board near the cutouts for the post to minimize splitting, and then secured the cut board into place using the screws. Throughout the decking process, I let the deck boards float along to make a straight line cut at this point. To do so, I made a chalk line and started with a plunge cut on the line and then worked in one direction. Then I turned around and finished the cut in the other direction. When removing old deck boards for the deck rebuild project, I came across a deck framing board with a rotted out hole that I felt needed to be addressed. So the first thing I did was try to vacuum out loose debris and sawdust to get a better look at the damaged area. Then I used a pick to test feel how solid the remaining wood was. I then used a chisel to try to remove the remaining softwood spots that I could. Now, I also created a little recessed channel in the stringer board where a surface crack was present, as this step will help in an upcoming repair step. The hole was deeper and in worse shape than I expected, however, I still felt I could repair the damage at least to the point where any future rotting potential could be minimized. I vacuumed the hole one last time to clean out the hole before proceeding. Then I took a long deck screw and screwed it into the good wood below the hole. I left the top half of the screw up in the hole to help act as an anchor for the resin filling compounds. I started with fiberglass resin, mixing in the appropriate amount of hardener. I then added the resin into the hole. Now the concept here is the thin liquid resin would work its way into any cracks and fill voids deep in the wood, sealing off future water penetration and perhaps even adding some strength. I also added resin to the surface channel I created to seal off that crack. I let the resin cure to a hardened state and then mixed up another batch for a second fill application. In this pour, I added another couple screws that would stick partially in this resin to anchor the additional layers to be added. I then let the resin cure. Now the plan from this point was to fill the rest of the hole with a two-part filler compound similar to auto body repair compounds. Like with the resin before, I mixed up a small batch with the appropriate amount of hardener. I then added the first layer into the hole, trying to fill the bottom and cover the edges. It didn't look pretty, but the hole was getting filled. I let this application harden, then prepared another batch of filler by mixing in the hardener. With this mix, I was able to fill the rest of the hole and smooth out the surface. And after hardening, I used a coarse grit sanding block to smooth down any raised areas so there would not be any interference with the deck boards. The framing board is completely filled and now water should not be able to penetrate. For insurance, I decided to attach another framing board to this repaired one to add additional structure and a better spot to screw the new deck boards to. So for this next step, what I'm going to do is use a 2x4 as sort of the top of the railing. And what this is going to do two things. One, it's going to kind of give a nice aesthetic end to the railing. And two, it's going to beef up our railing as well. So it's going to allow us to tie this into this. That's just going to give it more structure and more strength. And it should work out pretty well. And I'm going to attach this just using the same stainless screws that we're using for the decking. I'm going to run some screws down the length of the rail and then also into the 4x4 tops.
Now for the corner cap connection, I decided on a half lap joint. And I have one end cut already here. The other board will be cut similarly to allow the boards to overlap each other. This connection will allow both railing caps to be anchored to the corner post and tie the railing cap boards together. Each board needs to have half of its thickness removed the width of the board. So in this case, 3/4 of an inch will be removed 3.5 inches from the end of the board. I carefully set the depth of my saw blade to reach 3/4 of an inch. Then I use a speed square to line up the saw to carefully make my first cut along the mark edge for the space to be cut out. Then I moved the saw slightly further to the edge of the board and made another cut. I continued to make several more cuts to the edge of the board. This made small wedges of wood that could be tapped out using a hammer. I then removed any rough edges remaining with a chisel and fine-tuned with an even more delicate chisel. Now the goal here was to just get a relatively flat surface. It didn't have to be perfect considering this is a deck railing and not a high-end cabinet project. In any case, I finished up the joint edge with some sandpaper, which really smoothed things out. Now I could test fit the joint and it fit great. To secure the joint, I pre-drilled for 4 screws to minimize the chance for any wood splitting. I then installed 3-inch stainless steel decking screws and ended up with a nice looking structurally sound railing cap joint. In my opinion, this is a better option than simply miter cutting the boards for the corner joint. The half lap joint should hide the effects of wood shrinkage better. And please share your opinions and our preferred joint options when working with wood.
So in this video, I'm going to show you how I installed cable railing on this brand new deck I built. And the very first part of this was obviously the design. With the design, then I figured out what materials I needed. So with these railing kits come different fittings for different applications. So I chose the fittings that worked for me. In this case, I used a lag connection fitting. Now this is a termination that lags into a piece of wood, in this case a 4x4. At the other end, I needed the cable tensioners, and I got 2 different kinds in this case. One was a tensioner where the apparatus screws into the 4x4 post, and then there's an actual tensioning system built right in. And then 2 was a bolt system that you actually bolt through the post, and then you can tighten that bolt to provide tension. And using both of those worked well for this application. So one of the easiest things about using this system is this little template you can get it. This really makes life a lot easier. Essentially what it does is it provides the adequate spacing between the cables. So all I need to do is use this as my drilling template and we're good to go. So I make sure to start the first hole at 3 inches down.
I'm going to use clamps to hold the template in place. Then I slightly drill into the holes to mark locations for the lag anchors. Then I remove the template and drill into the post, drilling a depth adequate for the length of the lag fittings. Next, I find the lag studs and corresponding wrench that came with the Rail Easy installation tools. I insert the lags into the pre-drill hole locations and tighten them into position using the wrench. Note, it is important not to tighten the compression caps at this point. I learned this the hard way. A little bit more on that later. On the opposite post, I would install the Rail Easy studs, which go through the entire post and provide the ability to tension the cables. I used the same template to mark locations for the studs. This time I had to drill through the entire width of the post using a bit the same diameter of the stud fittings. To help keep the hole straight and plumb, I used a speed square as a drill guide. Now the studs come with a couple of nuts and a washer on them, so those needed to be removed to insert the hardware through the post. On the other side, I replace the washer and loosely tighten the nut as well as the cap nut for the time being. I repeated this process to install all of the cable studs. To install the cables, I carefully remove the stud compression cones. Inside the cone is a wedge fitting. I have to slide the cone fitting onto the cable first, followed by the compression wedge. Then I could install the cable into the lag post, but I had to make sure to thread the cable into the washer that often sticks on the lag post when the cone is removed. With the cable inserted, I slide the wedge in the cone up to the threads on the lag post and hand thread the cone into place. Then I use 2 wrenches to tighten the compression cone down snugly. This binds the cable into a locked position. Then I stretch the cable to the corner post with the studs. I line up the cable with the length of the cone cap fitting, then use the Rail Easy cable cutter to cut the cable to length. Now, like before, I remove the cone and wedge and place the cone on the cable first and then the wedge. As you can see here, you have to be careful of the washer that often stays on the stud. I carefully thread the washer onto the cable and push the cable into the stud. I hand thread the cap into place and then further tighten using 2 wrenches. Note, make sure you are free of the cables when you lock them in so you don't tie yourself in. I then repeat the cable attachment process for each cable. To tighten the cables, I remove the acorn nut from the stud connector and tighten the tensioning nut with the appropriate wrench. I also hold a wrench on the other side of the stud to keep the cable from turning while tightening. This tightening process was repeated on each cable, working from the middle out to the top and bottom until all cables were nice and snug.
Now I left these bolts long, however you could come back and cut them down and make sure the aesthetic nuts are more flush. But for now I'm going to leave them like this in case I need to do any more adjusting. Installing this cable railing was pretty simple. On this side I just ran the through bolt connections through this 4x4 and we've had 8 cables down, and again they're spaced 3 inches because we use the template that was provided, and again we have a 3-inch space here and a 3-inch space here, and these are nice and snug. So that went really well. And next what I'm going to do is show you how I ran the long length of cables with a similar method, but instead of using these we're going to use a different connection. The cable connection itself is the same, but where it attaches to the 4x4 is a little bit different. So I'm going to show you that next. Okay, so one of the problems when I tightened the original lag bolts first is I ended up tightening this a little bit and it compressed this enough where I can't get this cable through here. So that's a problem. So I gotta figure out how to expand this thing out to make it work. So what I'm gonna do is try to take a nail and put it through here and then compress it with this. See what happens. Just kind of take this, just turn it just a little bit. You don't have to get it too much. See if that worked. So now I turn around and put the nail on the bottom of this thing to pry it a little bit on the bottom too. Just a little bit. All right, see what we got now. So now the moment of truth. Aha, beautimous. So that worked, thank goodness. But again, the takeaway is to not compress these until your cable's in there and ready to go, because they're not very forgiving. So now I'm getting ready to start the cable on the long side. This is gonna be about a 20-foot cable run. But again, I'm gonna start with my drill bit, the right drill bit. This one, I've already marked it with some tape. And I'm just gonna start my holes with the bit. Another thing to note here is I started this first hole at 3 inches down, and then I know the remaining holes are 3 inches apart, and then this space down here is no more than 3 inches as well. These are the bolts going in. Put a little piece of tape on the bit so I know where to stop. You'll notice the way I put this 4x4 on the wall was with these 2 concrete anchors here. And I made sure I spaced those concrete anchors just right to avoid our drilling spots. So that was all in the planning. And I got lucky it worked out. Just realized my hat was on sideways, sorry about that. Now what I'm gonna do is take these lag fittings and then thread them into these holes. And I'm going to use a wrench to get it done. In this case, I need the 7/16. And I start by hand tightening it. And one thing to be mindful of here is not to tighten these fittings down here. These are the fittings that crimp onto the cable. You don't want to snug those up now. As I learned kind of the hard way on the other side, if you snug those up now, you could actually compress the compression fitting in there, and you don't want to do that now. So I want to make sure just to use this nut here to tighten these lags. Another way to do this is you can slide this over like this. Again, you don't want to tighten this one. Go all the way over, and then you could slide it back, bite it again, might go a little quicker this way. As I tighten these down, I just want to go to where the threads are in the 4x4. I want to leave a little bit of that extra space sticking out. This is for aesthetic reasons, and also if I need to maybe tighten a little bit on this end, it gives me the freedom to do that. Most of the tension is going to be done, if not all the tension is going to be done on the other side with our tension fittings. Now we need to drill holes so we can put the cables through our 4x4 post. Now in this case, I believe this system requires that the cable doesn't hang any more than 4 feet apart. So when I installed these 4x4 posts, I installed them no wider than 4 feet apart. And then now what I need to do is take the drill bit that came with the toolkit and drill through. So what I'm going to do now is I've got this up, the template ready to go. I'm going to start my holes, and then I'll come back and I'll use a speed score like this to kind of make sure I keep the bit nice and straight. So there we go, all the holes are drilled in this post, and I'll repeat this process on all the posts until I get all the way to the other side. Okay, so now that we are at our termination point, I'm going to install a little bit different setup here. This is the tensioner dead end essentially. So these screw in like this, and then they allow us to tighten the cable. However, it's a different attachment than what I've shown before. In this case, we have these 3 little screw holes. So what I need to do is these little holes here mark the locations of these little screw holes. So I'm just going to use my drill to mark those locations. Then I'm going to come back with some stainless steel screws and attach these. And this is actually the bit that came with the Real Easy toolkit. I'm guessing this is a 1/8 bit, and that's what we're using. I'll just pre-drill my holes a little bit deeper. In their toolkit, they even provide the right bit for the mounting screws that come with them. There we go. So there we go. Now that we got all our tensioners installed, I can go ahead and start running the cable. These are ready to go. Now it's time to run the cable. And when you open this stuff up, it becomes a mess. So I don't know if there's a better way to do it, but you just gotta be careful when you open it up, and there's really no easy way to organize it. So I'm just gonna feed it through. I'm start at the bottom, feed it through, go all the way across, and I'm gonna do one cable at a time. Now that we've got it down at this end, I can go ahead and insert this cable into this fitting and snug it down. And I'm going to show you how I do that here right now. Unthread this piece and be careful. There's a little washer right there. You don't want it to fall off. And then shove this through. Let's see, we've got this fitting here. Push that down so the little wire comes out. And then push this through the washer. Washer on. Push it through. hand. Once you get it snug, we're going to take 2 7/16 wrenches, and then I can tighten it. Nice and snug. Okay, so down at this end, what I want to do is have this bolt threaded out a good ways, about an inch or so at least. Longer the run, probably the more. I think you can go max 1.5 inches. And then we want to do is pull our cable tight and cut it right there. You want to cut the cable just right. You don't want to cut it too long. So you cut it too long, you're screwed. If you cut it too short, you're screwed. So you want to line it up right where it needs to be cut. And then take it and squeeze real hard and cut it. Okay, now that it's cut, this connection, similar to the other side, you can probably undo this a hair more. Oh shoot. You gotta watch out for this washer here. We take the cap, put that on first, the compression fitting, slide that on. Then you want to make sure to go over the washer. And kind of tighten that down. Kind of hand loosen it now. I don't want to over tighten it right yet. Okay, got that. And now that I got it in there, I want to tighten this down to get that compression fitting just right. So I'm going to use the 2 wrenches that came with the toolkit, a 3/8 and a 7/16. 3/8 goes on this side. And then we can crank this down. Okay, there we go. 1 down, 7 more to go. To tighten this up, we take the 3/8 wrench like here and the 7/16 inch and snug her down. Okay, 1 more. And if you're confident that everything's in there the way it can be, instead of taking it all apart, you can actually just slide this in, push it all the way in, and then tighten it down. But I'm just going to screw this off just to make sure. See, I don't like that method because it didn't go through the washer and it didn't seep through. So I like to take it off and confirm and tighten it down. Take the 2 wrenches. I'm just finishing up my last wire here, and this is the only cable I have left over. So I cut it real close, but if you're confident in your measurements, your cable, you can order it just right. Ah, mother, I just dropped that thing all the way downstairs. But if you're real confident in your lengths, you can order pretty close. But it might be a good idea with this system, if you've never used it before, get a little bit more cable and definitely a few more fittings just to experiment with in case something goes wrong. Because if you do hook these up and it's not right, I don't think there's any way you can salvage them. I think you have to get a new fitting. So just an FYI there. But this is the last one. Once I go get my part, put it in there and boom. And I'm going to pull my cable hand tight to about the end of the threads there. Put it in there, squeeze real hard. Boom. So again, slide this on first. Take the compression barrel, windy side down. Okay, and to tighten these, we just do this. And I'm just going to get them relatively snug. There's a tightening order here. They want us to tighten the middle one first, which would be one of these 2, and then you go 1, 2, 3, 4, 5, like that, basically all the way up. So this will be your number 1, this will be your number 2, be your number 3, be your number 4, that one's kind of loose, 5, 6, okay. So we're going to tighten, we're going to use the 3/8 on here. And just tighten this thing down. And then once everything's nice and tight, we just take this lock nut, lock it down. We are good to go. So thanks for watching. If you found this video helpful, please consider subscribing. I'm Joe Kistel.